To find the greatest common factor of polynomials, we will follow the same process, except we're going to remove or factor out the greatest common factor and show that using the distributive property. So first we will identify the greatest common factor between the two terms. And since this term doesn't have a variable in it, we're really only looking for the greatest common factor between the two numbers. And that would be 5. So we would write a 5 and then an open set of parentheses. 5 then goes into 5a, a times, because a times 5 equals 5a. And 5 goes into 15 positive 3 times. So we would rewrite 5a plus 15 as 5 parentheses a plus 3. And you can check this with the distributive property. 5 times a would be 5a, and 5 times positive 3 would be positive 15. Looking at this binomial, 56z plus 8, the greatest common factor between the numbers is 8. And 8 goes into 56z 7z times. And 8 goes into 8 positive 1 time. We can check this again by distributing. 8 times 7z would be 56z, and 8 times positive 1 would be positive 8. Here, when we have variables in both terms, our greatest common factor will include that variable, assuming that the variables are the same like they are here. My coefficient here is 1. My coefficient here is 2. So the greatest common factor between 1 and 2 is just 1. So we don't really need to write the 1. This has 3 factors of y in it, and this term only has 1 factor of y in it. So y is the greatest common factor between these two terms. Y times y squared will get you y to the third, and y times positive 2 will get you positive 2y. And again, always check by distributing. Y times y squared is y to the third. Y times positive 2 is positive 2y. Here, we have coefficients and the same variable in both terms, so our greatest common factor may have a coefficient as well as a variable term, assuming that these two numbers are sharing a common factor. In this case, we can see that the greatest common factor between 5 and 10 is 5. And now when we look at the variables, this term has 3 factors of x. This term has 4 factors of x. They both have at least 3 factors of x, so x to the third power is now our greatest common factor. 5x to the third times 1 will be 5x to the third, so we have to include the 1 here. 5 times 2 is 10, so that's positive 2. And x to the third times x gives you x to the fourth. So 5x to the third, parentheses, 1 plus 2x, is this greatest common factor shown as multiplication over this binomial to produce this. And we'll check again, always by distributing. 5x to the third times 1 is 5x to the third. 5x to the third times positive 2x, well, 5 times positive 2 is positive 10. And x to the third times x to the first is x to the fourth, so I know that I'm correct. We may also run into this with a trinomial, in which case we have to find the greatest common factor of the 3 numbers. We can use the method listed in a prior video to see that between 16, 8, and negative 12, the greatest common factor is 4. Now we need to look at the variables. Well, here there are 5 factors of z. Here there are only 3 factors of z, and here there's only 1 factor of z, so 4z is the greatest common factor of these 3 terms. 4z goes into 16z, well, 4 goes into 16 4 times, and z goes into z to the 5th, z to the 4th times. 4 goes into positive 8, positive 2 times. Z goes into z to the 3rd, z squared times. 4 goes into negative 12, negative 3 times, and z goes into c once, so we don't need to write it. So let's double check this with the distributive property to make sure that these are equal. 4z times 4z to the 4th, well, 4 times 4 is 16. Z to the 1st times z to the 4th is z to the 5th, so that's correct. 4 times positive 2 is positive 8. Z to the 1st times z to the 2nd is z to the 3rd, so this one's correct. 4 times negative 3 is negative 12, and z times no variable here at all is just z, so I know that we've done this correct. Pretty soon, we're going to be encountering expressions like this that may look different than here. But notice that inside the parentheses, we have identical binomials. So we're really taking x times something plus 3 times that something, and this simplifies to x plus 3 times that something.